Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. This is your co-host, Aaron, for a quick intro this week. Today's topic is the evolution of data platforms. This is a topic Brian and I have talked about off-air quite a lot recently as the data center and cloud services kind of evolve to support the next generation of applications, namely AI. Now, how do GPUs impact these new patterns? How is data stored? And how do we balance some of the older technologies, such as virtualization, against these new requirements? We're going to dig into that and more right after this break.
Panoptica, Cisco's cloud application security solution, provides end-to-end lifecycle protection for cloud-native application environments. It empowers organizations to safeguard their APIs, serverless functions, containers, and Kubernetes environments. Panoptica ensures comprehensive cloud security, compliance, and monitoring at scale, offering deep visibility, contextual risk assessments, and actionable remediation insights for all your cloud assets. Powered by graph-based technology, Panoptica's attack path engine prioritizes and offers dynamic remediation for vulnerable attack vectors, helping security teams quickly identify and remediate potential risks across cloud infrastructures. Panoptica utilizes advanced attack path analysis, root cause analysis, and dynamic remediation techniques to reveal potential risks from an attacker's point of view. Visit panoptica.app to learn more today. That's panoptica.app. And we're back, and I'm your host, Brian Gracely. Welcome back to the Cloudcast. You know, folks, one of the things that we've been dealing with, especially as we've been really kind of dealing with the intersection of both cloud computing, which we've obviously done for a long time. We've been talking about the impacts and all the different aspects that AI is having on your businesses, your architectures, the way you're thinking about applications, is to really kind of, understand not just kind of where the hype is with AI, but also how is that going to impact kind of the things that you have to deal with day to day. So everything from, what's this doing to your data centers? What is this doing in terms of how you're managing data, how you are thinking about security around that? And today we really kind of want to dive into, more of the data-centric side of this. What does it mean to store large amounts of data, whether it's around models or whether that's around augmenting models and applications? What's that going to mean in terms of performance and latency? And so really excited to kind of dig into that and all aspects of that with Jeff Denworth, who is co-founder of Vast Data. Jeff, welcome to the show. Great to have you on.
Hey, Brian. Jen Denworth, only on Fridays. Kidding. No, it's Jeff. Yeah, nice to be here.
Yeah, no, good to be with you.
Finally on.
Absolutely. We before we dive into Vast and sort of all the things that you guys are working on today, because there's a lot of uptake around the technology. Give us a little bit of your background. You've been working in this space for a while. You've got working with a team that's extremely experienced in this. But give us a little bit of background, prior to Vast, and then what was really kind of the drive that led you guys to start the company and bring it to where it is today.
Sure. So I think it's probably fair to say that my background is in high performance computing and very high scale storage infrastructures. I've been at it for about 25 years now. Started with some of the early big Linux systems that a lot of national labs and large companies were building, feeding those machines with a ton of data. And my career has just kind of evolved from there, where I tend to kind of operate in circles where people think about extreme levels of scale. So my specialization is really on the go-to-market side. I work in sales and product marketing and marketing and alliances, and I'm kind of helping the go-to-market side of Vast Data. Yeah,
no, it makes sense, and I know that the team behind Vast has quite a bit of expertise and really kind of been innovative, both what you're doing today, but also prior to that. Let's dive a little bit into. Before we dive into the company specifically, kind of around the trends that are shaping the market right now. When people think about AI right now and they're thinking about it in terms of cloud architectures and data center architectures, so much of the conversation is around GPUs, right? Like GPUs are sort of the, compute is king center of the conversation. But that's only part of the conversation. What's this doing to the storage side of things, to the data side of things? Whether it's from a scale perspective, whether it's from a performance and architecture perspective, like what are the, I don't know, 3 or 4 big sort of impactful things that are happening that people that live in storage land and data land are having to think about and really maybe even rethink as they start to deal with a lot of AI things and big models and so forth?
Sure. So maybe let's start with how the models are built.
Sure.
Kind of like in the beginning of time. So today, if you're one of the large language model builders, actually curating a data set is probably the most important part of the job. I read an interesting, I guess it was a tweet or maybe like a little micro blog post from somebody from OpenAI that said, at the end of the day, if you took a data set and you train that with either GPT-4 or Bard or Gemini or whatever, and you kept using that same data set to train those models over and over and over, at some point they would converge to the same result that they would kind of express in terms of their ability to understand context and data. And so when you look at any of these large language models, you're not seeing the architecture of the model so much as you're seeing the data set that was used to train the model. And so that to us is really interesting because, a lot of people talk about things like GPUs and other AI processors, but data curation, data processing, data refinement is the absolute most important part of all of these model builders' jobs. The training is just a function of large scale machinery that they use to ultimately run these models once they've got that data set assembled. So data is really at the heart of this new model creation process. And we'll talk about it in a moment, but VAST has been fortunate to kind of help a lot of the world's largest large language model builders do things like prep and train their data. And so now you've got this model that, is kind of being built by the likes of the hyperscalers. What do you do with that? Well, what's happening around the world is that either those organizations or just standard enterprises are taking these models and figuring out ways to fine tune them to the lexicon and the context that a business may have, right? If I'm, say, like Johnson & Johnson, and I take something that comes from Facebook or Meta in the form of Llama 3, then I have to go and kind of refine that model so it understands things like, Q-tips and baby powder and other stuff. And so that's a refinement of a model that's more context specific. And that can be done with relatively smaller infrastructure and an additional data set that you expose to that model for fine tuning. And at that point, what you have is a model that then understands the vernacular or the language of an enterprise. And so I'd say that's what we see happening all around the world right now is large organizations are taking these things that either come from open source or commercial offerings and then fine-tuning them to meet the needs of their businesses. And then there's a whole range of data that actually has to sit on the outside of a model. If I take, for example, I don't know if you've used GPT-4o. Have you used that?
Yep.
Okay. So there's a new cool feature that's kind of not so obvious when you use it, where you ask GPT-4o a question, and if it doesn't know the answer instantaneously, what it says is searching the web. And really what's happening is that the OpenAI team went out and indexed the entire internet. It isn't just like calling to Google and trying to figure out what page ranks are. The OpenAI team has gone out and basically re-indexed the internet in the way that Google has. And so this is a process called RAG, which stands for Retrieval Augmented Generative AI. And a language model or any sort of AI model can only fit a certain amount of data in the memory of a GPU or a collection of GPUs. And so the question then becomes, if I have this whole big corpus of information that I want to learn from and serve up to my employees or my users, if I'm building a SaaS app, what do you do with that? Well, then you just go and you take an ancillary data set and you run it through a second process where you basically analyze and index all that data at the content level. And using something called a vector database, that data can then be retrieved by an LLM by querying the vector database for the kind of the nearest answer to the question that's been asked. And so the abbreviation of that concept is called RAG, and I think that is going to be the most pervasive enterprise use case over a long enough period of time, because A, there's just so much data that doesn't fit in a model, and B, there's a lot of cases where you don't want to have a model be infused with new data, because the data that you actually are sitting on is so sensitive that it needs to stay outside the boundaries of AI.
Yeah, no, and that makes sense. I think a lot of people have spent the last year, maybe year plus or so, understanding concepts like RAG. They're understanding what can I do to adapt a model. Can I train it myself? Is that the best way to train it? And then, like you said, they're dealing with the challenge of saying these foundational models are incredible in terms of what they've indexed, but they don't necessarily have my data. My data may or may not change quite a bit, or it may be very static. And so I think they're going through a lot of, understanding and learning of, how do we deal with this? Because to some extent, it sort of feels like a database, but at the same time, it's vastly, vastly different than what they know with databases and other things. So, it makes a ton of sense. It's a good branding and framing.
And the crazy thing is the creating embeddings on the data, right? Somebody once described it to me as, if your data is a word, right? Like cat, then the embedding may be something in the order of 10 times the size of that in terms of its storage payload. So now certain customers are coming to us saying, if I actually want to go and like activate this data and expose it through an LLM, which basically becomes a context and a query interpreter, I need 10 times more storage than I needed previously, which is wild.
Right. Well, and that sort of leads me to the next question I would have, which is the VAST platform, and even the work that your team had done previously had really been kind of cutting edge on all flash types of storage systems and data systems, right? Which were just a huge leap for anybody that doesn't live in that domain, just a huge leap from kind of spinning disks and, kind of standard, hard drives. But obviously the cost of flash, is a step up from that. And obviously it's come down somewhat. When you get people that understand, okay, like you said, that example where the data that you think you have, whatever it might be in terms of terabytes or gigabytes, but to get output from it is 3 times, 5 times, 10x. What do they start thinking in terms of that sort of economic model? Is this reshaping storage and data management models, or is there technology that's helping to bring that back in line?
Well, that was the whole reason we started the company. So maybe just a little bit of a background.
Sure.
We started the company in 2016, Vast Data, to basically simplify the way that customers could store and process on their data, which sounds like such a kind of a simple thing to say. But when we started, the early problem statement was refined by companies. We were watching companies like Baidu and Uber and Meta and Google, and all these early deep learning research teams were doing amazing things like teaching a car how to drive, or finding cats in videos, and what we saw here was a possibility, or maybe a probability, depending upon who you talk to, that the deep learning would completely change the way that applications work. And what the kind of the overarching theme for all of these efforts was that data was defining the accuracy of these models. And so if you think about deep learning as just applied statistics, a statistical model can become better and better as you show it more and more accurate data. And so foundational thesis number one of VAST is we wanted to build this massively scalable system that could hold all of the world's data and unlock access to it such that any organization, big or small, could basically get real-time access to everything. Now, Brian, to your point, the key thing that we had to work on in the early days was, okay, well, if you want to put everything in the system and it needs to be real-time, then you have to solve for the cost of flash problem. Because back in 2016, it was like 40 times more than a hard drive-based archive. Nobody's going to pay for that. It doesn't matter how smart your chatbots are. It's just the return isn't there. And so we started by essentially thinking beyond what an architecture that was laid down by Google 20 years ago allows customers to do. And so in 2003, they wrote this white paper about something called the Google file system. And any scalable architecture that's followed there is basically kind of mirrored the architecture that Google laid down, where you take a commodity server, you put some drives in it, and then you stitch together namespaces for like storage or file storage or backup systems or hyperconverged systems or databases. All of it kind of echoes what Google did. And you stitch together these servers to create really, really large data sets that obviously can, kind of power enterprise businesses or cloud businesses. And so there's a variety of challenges that architecture has introduced that we saw could be better served by what we think is the first new modern systems architecture in the last 20 years, where imagine something that looks more like a server, but abstracted all the way to data center scale, where you just have like hundreds of thousands of stateless cores that run in containers that don't each manage a partition of a system, but rather all of the cores see one global data set. And so with that, none of the cores need to talk to each other as they're running the system's logic. And you can build something that is completely parallel, because basically what the system does is it eliminates any east-west traffic for any sort of I/O operation. So this was really big, because now you can do things like, you can build a system that can support any level of GPU scalability on parallel workloads. You can build a system that is a data warehouse that has support for full real-time streaming, like the scaling properties of Hadoop with the streaming performance of Kafka. And so all these new capabilities come into play if you rethink architecture at the most fundamental level, but we still had to solve the cost of flash problem. And so what we did is we implemented three kind of techniques that we layer on top of this low-cost flash that we use to extend the lifespan of a flash device by 10 years, to bring the cost of data protection just down to 3%. And then finally, we've built this new global correlative compression scheme that you could think of as, if you could zip up your entire data center into just one file, that's roughly the gains that you see on our approach, where customers get like 3 to 5 times more infrastructure from their hardware than what the hardware naturally allows through this new form of data reduction. So it's really cool. And actually, when we work with these large language model builders, they see between 2 to 3x data reduction, and that just makes it possible to afford flash for all of your data.
Interesting.
And so yeah, it's a big thing, the cost. And now we've also been studying the power impact of all of this. And what we just realized actually this morning is that per every exabyte you deploy, and we think and talk in exabyte terms, you can basically save about a megawatt of power by not putting your data on hard drives, but rather use flash. So it's kind of a nice offset to a lot of this GPU work that's being done right now. These things are like 100 kilowatts per rack. And we come in and, we're saving customers at least kilowatts, sometimes way more.
Yeah, no, it's interesting because, to get the equation to something that, whether the equation becomes sort of neutral, you're offsetting the GPUs, or you can get it to, be the curve going in the right direction. It starts to, because so much of the AI stuff is still so new to people. If the the financial burden of it is so huge, you're going to just get a lot of people that sort of go, well, I'll wait a year, I'll wait 2 years, I'll wait 3 years, and on the flip side of things, you've got the GPU manufacturers, the NVIDIAs of the world, telling people if you're late by a month in building your model, you're gonna miss out on huge economic opportunities.
They measure that, by the way, at $100 million per month.
Yeah.
Seriously, that's the calculus. Actually, that was the calculus in January. It might have changed. Now that you see OpenAI in the billions of ARR, they might actually increase that. I don't know.
Right. in that same context, now that you guys are putting a system in place that allows people to say, okay, from a data perspective, we can sort of scale as we need to. We can take advantage of these things. What are you seeing in terms of actual adoption within enterprises? So outside of the model builders, being able to do this, are you beginning to see the Gen AI technologies being put into use in the enterprise, and maybe what are some of those things that you're seeing more frequently than others in terms of use cases?
Sure. Well, I think it's important to understand that we travel in some different circles, only because the product is more than a storage system. Today it supports a file, object, and table storage environment that is either used for unstructured data, or in the case of the table store, it's also a transactional enterprise data warehouse that has its own query engine embedded into it. And so we've basically blurred the lines between what you can think of as a conventional unstructured storage system like a file system or an object store, and a structured environment into one unified system. And the thinking was, okay, well, if you're going to run a picture through a convolutional neural network and figure out that there's a cat in it, well, that cat needs to live somewhere. The expression of a cat needs to live somewhere in a kind of in a transactional environment that you can also query into, so that you can start to query your unstructured data. So we built these two together. And then the final thing that we're now just getting off the line is the ability to run functions on this data, so we can basically bring it to life through things like inference operations. And so we call it the vast data platform for reasons that we think of it as something that is more than just a storage system. And where we travel, we find different AI maturity curves, right? So if you talk to a conventional big data team, I think a lot of these organizations are now, we oftentimes will see a title in an enterprise that's just called data platforms. And the data platform teams are the ones that are being pulled into these AI initiatives, because data preparation and data engineering is the hardest part of the job. Like once you've got everything built, then you give the model training set to some GPU provider, some GPU cloud, and they go and do the training on your behalf. But really, the data prep is the hard thing. So it turns out that machine learning has been something that a lot of data lakes have been kind of working with for a very long time. And it becomes a natural progression for the big data teams to also support the deep learning initiatives. Now, outside of data science, I would say we only see deep AI projects that are taking root on almost a service or a product basis. So, you go to the average CIO and you say, "What's your AI strategy?" You see the kind of normal checkbox. Okay, I've got Copilot running for the code that I'm developing. I've gotten my employees all licenses for ChatGPT. And then outside of that, it typically becomes lines of business or product owners that are looking for ways to inform the products that they're offering with AI. So the easiest example is like an automotive company, right? Okay, I've got a car. I'm trying to instrument it with more autonomous capabilities. And those teams are going crazy with AI, obviously. You can see in the press Tesla talking about buying hundreds of thousands of GPUs and sitting on exabytes of data. And you see that in healthcare, you see it in banking, you see it in a number of different vertical markets where autonomy can inform how people deliver products and services out into the market. Now, back to that CIO, I think probably this RAG experience that we just talked about will be the common use case that you see pretty much every organization evolve to once they check those first two check boxes for copilots and GPT support. And every CIO I talk to basically starts the conversation with saying, "Do you have a vector database?" And
right,
it goes from there.
Yeah,
so
that was going to be my follow-up. Is as you think about your data system, it does block storage, file, table. Do you start to see the convergence of things like vector databases or vector capabilities into data systems, or do you think they stay sort of separate entities or separate systems with separate teams managing them?
That's a great question. So I kind of have to be careful what I say here. I think it's a great pairing, right? And I'll simply say the manifest destiny of any infrastructure provider that focuses on data systems should be to expose that data in a way that provides context to an organization. And so, you mentioned a few kind of protocols like, you've got S3 or NFS or block storage or whatever. Underneath all of that is actual information that storage protocols have never understood. SQL gets a little bit better, but it's still something where you need to have almost a human interpret of that by understanding things like SQL syntax and structured query language. Now, if I look beyond that, an LLM doesn't need any of that. And so all it needs is embeddings, and it needs context windows. And I really think, anybody that's serious about solving AI for the masses needs to be thinking about taking their storage systems and just bringing much more insight out of them than what we've been doing up until now.
Yeah. Yeah. And I didn't mean to ask that to sort of put you on the spot. I was just curious because
it's fun.
Well, in the past, we've never seen, databases sort of were their own thing, even though in many cases people think of them as storage engines and data engines. So it was more along the lines of, as somebody who lives in this space, do you see lines blurring of sort of database / storage systems, and that may have been one of those use cases. I guess another question in that domain is, for any CIO, obviously AI is a big deal these days. Like you said, it may be on a project by project basis. It may be looking longer term as to, architecturally, how does this impact a lot of things? How are you seeing, as you're talking to CIOs, you're talking to chief architects, how are they sort of balancing on one hand, the demands around AI, or the demands around the possibilities of AI, right? How it could change your business, how it changes your products, how you interact with customers, with sort of the day-to-day challenges they have of some of the infrastructure modernization things, right? Like, so, VMware coming along and saying, hey, we're increasing your bill and so forth. From a data perspective, since you guys interact with both of those worlds, like, how are you seeing the two kind of coexisting? How are people prioritizing stuff? Is it efficiency on one hand and performance and scale on the other, or how are you sort of seeing those two things playing out in the marketplace?
I think one is strategic and the other is reactive, right?
Sure.
Okay, I've got these 8 cloud apps that haven't been migrated yet. I've got VMware that needs to I have some sort of license renewal that I need to work on there. And these are things that CIOs have to do. It's, just like, buying new BlackBerries or something like that. On the flip side, the strategy piece is largely being, the CIO, I think, needs to be the midwife, as it were, for what the lines of business want to do to kind of improve their capabilities. And so the best thing that they can do is facilitate this and put boundaries on it in terms of data security, application security, and cost that can run away very quickly. But from an infrastructure perspective, our general thesis is there's not a single enterprise customer in the world that's ready for any of this at real scale, right? Earlier I mentioned 100 kilowatts per rack. That's like a real thing. If you want to... I was with an enterprise customer last night. We were at NVIDIA, and like their initial purchase that they're scoping out would be something like 10 megawatts for just one system of one cluster of GPUs. And so the first takeaway is that everybody either has to go to a GPU cloud, or you have to go to an organization like Equinix that can host some of this very, very power dense infrastructure. And so that's putting a lot of pressure on organizations at the cloud level to provide enterprise infrastructure that looks and feels like what the organization would have otherwise run on premises, that is now just not even a possibility because nobody's got idle megawatts sitting around.
Right.
And so that's why we've been working with a lot of the what are called the born in the age of AI clouds to build multi-tenant infrastructure that has a look and feel of an enterprise system like the CIOs of today should expect from the stuff that they've been using to manage their data all along. Customers that partners that we get to kind of talk about are organizations like CoreWeave or Lambda, or internationally, there's another one, Core42, that these guys are all spending billions of dollars building out this new generation of clouds. And the cool thing is they get to start from a blank sheet of paper. The hard thing is, they're playing catch up really quickly on enterprise capability, and that's where vast data comes in to kind of make sure the security's there and what have you. But yeah, we don't see a lot of CIOs driving AI projects. We see them facilitating the deployment of AI.
Yeah, makes sense. No, it makes sense. I mean, we saw that very much with cloud, where they may have started as sort of a central premise of what they were going to do, but the lines of business and the teams that are responsible end up owning them and driving them because they understand the timing of it faster. We've talked about a lot of things. We've talked about some of the architectural changes. We've talked about some of the economic changes. I want to wrap up with one last question. Between what you would classically have called a storage team and now what you're seeing with data teams or data platform teams, what are you seeing like skill wise that's having to change or adapt or collaborate that's different as we get into these worlds in which data scales differently? They've got to think about performance differently. They've got to think about economics differently. What on the people side of things? What's evolving there, and what are you seeing happen in that space?
So first, I would say cloud has made everyone dumber. Just in a general sense, like if you go back 10, 20 years ago, you had teams of people that really, really understood infrastructure and nuance for systems in a way that they don't have to think about anymore, because a lot of organizations can just swipe a credit card. So when we walk in, it needs to be almost a reprogramming of things that people learned maybe 10 or 20 years ago and forgot that they had to think about. It starts by kind of building from the ground up an understanding of how systems architectures work today, and B, an understanding of how they can work in the future thanks to some new innovations that are happening. But then the second thing that has to happen from kind of like a company platforming perspective is that once you can build a system that has no trade-offs around things like protocols or data processing capabilities or tiers or anything like that, you don't have to worry about any of this anymore. The second thing that our customers are realizing that they have to do is they have to work cross-functionally, because at the end of the day, excuse me, if you have one system that can kind of solve everything, and there's a lot of reasons for purposes of things like pipeline simplification and just overall efficiency, well, then you got to have a lot of people in the room that can appreciate the power of unifying systems. And so that historically has not happened. And a lot of our customers really work in silos. So architects are the kind of the key to this whole equation. And they are the ones that most need to study the art of possibility, because they can have the greatest impact on their organizations by bringing everyone together.
Yeah, no, it's interesting that you mentioned that in the data space and storage, and because where I'm hearing very much the same things, from friends and colleagues that are in the network space, is they're sort of saying, the role of the network architect is sort of dead, or those skills are sort of dying. So it is sort of interesting to see the correlation that cloud has had. And what's going to be, I think, really interesting is, especially given the amounts of data that we're dealing with here, and the concerns about privacy and the concerns about letting things mix into public models versus your private models, is how much stuff probably will be in private clouds, again, whether they're hosted somewhere or they're in your own data center. So yeah, it'll be interesting. I'm interested that you're seeing a similar thing on the data side that people are seeing on the network side of, those skills have quickly deteriorated, or they're not there as much, but they may sort of be coming back around as being really, really critical. So it'll be an interesting trend to watch.
I also think the vendors have kind of let this problem run away. And what I mean here is like, okay, so I'll take earlier I talked about self-driving cars. If you go and you want to build like an ADAS pipeline and you go to a tier 1 cloud service provider, a lot of the stuff that they're offering is not necessarily born in the age of AI. And it's definitely, half of it's not even stuff that they invented themselves. They're just packaging and kind of building as service offering. And so if I want to build an ADAS pipeline, I need 40 to 50 different services from a modern cloud vendor to stitch this all together, of which I think there's like 10 to 15 different types of data storage, 10 different types of processing systems. And it's a game of incrementalism that we've been playing for the last few decades, where all these vendors work on different parts of the problem and nobody's trying to solve the whole problem. And so this is where I think the real opportunity is, if architects can take 2 steps back and say, like, what's the ultimate problem we're trying to solve? And realize that there are now simpler solutions, it can be a lot of fun. And for that reason, Vast has been growing faster than pretty much any company in market history, because we're bringing everybody back to first principles.
Yeah, no, you highlight something that we hear quite a bit from people that have been doing all sorts of things in the cloud, is that, while the number of primitives that were available to you were interesting as they were coming out, and it was sort of, it was different when you had these building blocks, they're now, a lot of them looking at it and they're going, how do I stitch all these things together? Why can't there just be, 1 or 2 things that I have to deal with, as opposed to, like you said, a dozen or sometimes maybe more. So yeah, no, that's very, very interesting insight in terms of not just, the hype around AI, the things you have to deal with scale, but, how does that impact the people and the way that they're going to architect things? Jeff, I want to be super conscious of your time, because I know you're a very busy man. You guys, like you said, you guys are growing very quickly. What are the best ways for folks that are, now looking at their data platform, they're now looking at the economics of their data platform? What's the best way for them to engage with the Vast team, to try and go solve some of these things?
We're always available online at vastdata.com. You can send us an email at hello@vastdata.com. And I think the thing that we love to do is just sit down and kind of look at the reasons behind the reasons that people do things. And we discover that there's just a ton of opportunity for optimization with the customers that we work with. So would love to talk about architecture, love to talk about invention, and explore the art of possible.
Good stuff. Good stuff. Well, thank you again for the time today, folks. On behalf of Aaron and myself, we want to thank Jeff for his time, for his insight. And with that, I'm gonna wrap it up. Thank you all for listening. Thanks for telling a friend about the show. Thanks for helping us grow the community. And with that, I'll wrap it up. We'll talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.